This is a flexible hose clamp. It was created in Creo 3. I've got it in this example, and here it is clamped onto this larger tube. I've got a smaller tube here, so I'm going to go ahead and place it just to show how it works. Let's assemble the clamp. It's called clamp. I'm going to use the flexibility, and instead of by value, I'm going to do a diameter of this. Select OK. Select OK. And zoom out a little bit and drag this into position. And I'm going to use this surface here and that surface there and drag it back over to here and line it up to that. Let's leave it like that. So as you can see, the clamp looks like a real clamp that is used in an assembly. This piece comes out as it gets smaller, and that's what we're going to model up. It's got the slots. It's a very detailed clamp. Watching the video, you could determine how much detail you want to put in yours, whether you want to make it a part or assembly. Right now it's existing as a part, but I used other parts to create it and just merged them. That was done for relations reasons. The screw also turns. If I open that, and I go to a cross section of this thing, you see that the slots are lined up, and that stays. If I make it smaller, this screw will turn to line it with those slots. So that's all done through relations, and you probably won't do that. You don't need it, but it's just an exercise in relations, and in this video we'll cover that. Also, this clamp is designed to go from this one here has got a max min, and you set those dimensions and it automatically creates the clamp for you. So this range here is from the catalog. I've got it out of a McMaster-Carr catalog, and I also downloaded the files from there that I need to take measurements from. But it's set up so that the clamp will not go beyond. If you use this in an assembly and somebody tries to put 5 inches for a clamp that only goes out to 2.625, 2 5/8, it will not. It will just go to 2 5/8 and stop. That's as big as it can go. It's set up through relations to stop it from doing that. So if somebody tries to use this on a wrong size hose, it will not behave. It will not go to that diameter. But as I said, this clamp could be copied and made larger. Like say if you need another range, just look in the catalog, and there's a whole family of clamps with this screw and housing assembly. There's a whole family of clamps. And to make a larger one, like for instance, if I want to make a larger clamp, this one's a 2. Let's say if I want to make a 4-inch clamp, I just hit 4, and it creates a 4-inch clamp for me. Regenerate, and there's my 4-inch clamp. And that's all set up for relations. Let me get this section out of there, deactivate. So there it is. And it does some calculations on how much should be sticking out here. It does a bunch of calculations. The only thing you really probably have to do is the number of slots you want in there. You might have to tweak that as you make a new clamp. And the max min diameter. So here's the diameters here. So this is the min. It won't go smaller than that. So let's change our minimum to say a 3. So it goes from 4 to 3. So now it's set up now that if I tried to make the clamp smaller than 3 in my assembly, it will not work. So let me just regenerate and show you that it won't go smaller than 3. So here's our flexible dimension here. I'm going to edit that and try to make that smaller than 3. Make it 2. And you can see it went to 3. Didn't go down to 2. I'll make that, regenerate that, and there we have our clamp. But it will refuse to go beyond your max min. There's our max min controls. So we'll set up relations for that. So let's begin. This clamp was created from a part that already exists on the internet. It was an IGIS that I downloaded. I went to McMaster-Carr's website and downloaded a couple files for a hose clamp, and it was an IGIS file. So let me go ahead and open that IGIS file. So I'm going to create a new part, and I'm going to call it the source band. And I'm going to get data, import, and here's the IGIS file that I downloaded. And I don't need log files. Okay. So this is what I got off the internet. So we're going to make our clamp look like this. Ours, of course, will be flexible, and a couple of added features we're going to put in there. We're also going to try to set it up so that we can make any size clamp with this size screw. There's a range of clamps that they make. We'll try to get ours to be able to make them all. The first thing I'm going to do is I'm going to break this eye just into the separate parts so I can take some measurements. I'm going to make a drawing of this so I can take some measurements. So what I'm going to do is I'm going to break it down into the band, the housing, and the screw. So I'm going to need to save a copy of this. So I'll do save as, save a copy, and I'll call this one the source screw. And I'll save a copy again. I'll call this one the source housing. Okay, so what I'll do is I'll take measurements from here. I could take measurements using analysis and measure, but I think it's faster to create a drawing. If you don't have a data doctor with your, I'm not sure if it comes with all versions of Creo, but on this one, the version I do have data doctor, so I can break this down into individual pieces, individual components, because the IGES was created from an assembly file. So they made an assembly of this thing. And if you have a data doctor, you can break it down. If you don't, you'll just have to take measurements and measure it yourself from one part, just like measure everything you can from here. Maybe just do some cross sections and take some measurements. But we have data doctor, so let's just get the band for this one. So we're going to go to the import feature again and edit definition. And here's data doctor here. And once you get it in the data doctor, the components show up over here. So I'm going to keep everything, but I don't need the screw. I don't need that housing. There's the band I need. I just don't need the housing and the screw. So let's just delete those and hit the check. And let's save that. So that's our band. And one quick thing, this purple piece did not come out as a solid, so we'll have to remember that. It's probably came in on some planes. It had some problems. Let's see which plane this thing. Oh, I think I'm gonna get rid of all these planes. Planes, layers. So I got rid of all those layers. My part has default layers, axis, curves, and planes. Also, we are going to be making some very small features, so your accuracy has to be set. I've got mine set for all my models is set, but I don't like using Creo's default. And to do that, I've got to go to my model properties. I've got it on my quick access toolbar, but you could find it here in the file, and then you'll find it prepare and in model properties. If you want this on your quick access, just right click and just add it. So let's go to model properties, and I've got mine here. And I've got mine set for absolute. By default, Creo has a relative. And all of my parts are absolute 1/1000th of an inch. All my inch parts are, this is my setting. So you'll need to set yours that way too if you're going to make an inch part anyway. Because we are going to be creating some small features. And your start part should be set up for that. So I'm just going to save that. And let's open up the rest of them and fix those up. So the band is done. Let's do the housing. So the same thing again. Go to data doctor and get rid of everything but the housing. You see the housing has a pocket up in there. And these pieces on top of the housing, that's actually part of the band. We're going to be modeling those in the band, so we'll have to get the data, the dimensional information from the housing here to get those top pieces done. So let's save that, and let's open the screw. And now I'm going to create a drawing. I'm just going to call it the source. And I don't want to use a default template. I'm just going to put it on a C size. So the first part is pulling in, this last part I had open, source screw, so that's fine. We'll do that. So my default part is source screw. So let's enter a general view. And let's do front for all of them, for a few front. And let's scale this up so our dimensions don't get too crowded. Let's make that like 6 times, maybe 8. Let's try 8. Try to fill up the sheet here. This is just so our dimensions don't get bunched up. So I'm going to make some couple projection views here. And I'm going to turn my layers off. And now I'm going to go add a sheet. And we're going to go get another model. So I'm going to go to drawing models, add a model, and let's do the housing next. Insert a general view. Front view. Okay. Scale it. Let's make this 6. Projection view. And projection view. And let's turn our layers off. And these pieces right here are going to be part of our band, and that's the part we're going to model first. So let me go ahead and dimension those up. So go to Annotation tab and hit Dimension. Creo 3 is a little bit different. Man, dimensioning drawings. You got to hold the Control key down now to I'm going to need this thickness too. I'm going to go 4 decimal places. I want to see the real numbers here. I don't want rounded to 2. I'll round to 3 just to make it a little bit more accurate. So I'll go to Properties and make them, let's just do 3 places is fine. I could default mine to that. With a config setting, but I do a lot of metric stuff and that's the way I like it, so I'm going to leave it alone. Okay, so we have all the dimensions we need from that view. I think we just need 1 dimension from this view. Okay, and let's add another sheet for the band. Let's go to our layout, drawing models, add a model, and let's put the band in. Insert a general view, front, and let's get that scaled up to say 3. Yeah, that's about right. Insert projection view, and a projection view again. And let's hide our layers. Save status. Okay, so all we're going to need is for the band, it's just going to be simple. We're going to do a spinal bend because we're going to go ahead and put these slots in there. So we're going to need to do a spinal bend. So we're going to do draw a spine, and it's going to have this little S in there. It's going to go around. Ours is going to go around about 3/4, so we'll have a 3/4 correct diameter, and then the band is going to go over and overlap. So we're going to have this overlap in there, and then we're going to create this purple piece. This piece is there for mounting our housing, and it's actually welded to the band. So let's go ahead and get some dimensions off of this. Let's take go to Annotate, Dimension, and Overall here. Oh. And we're just going to make this piece the same diameter as this, and we're going to let that change, even though in reality it doesn't, but we're just making a model that's going to not give us interference. In reality, this thing actually embeds itself into the hose, and we're not going to do all that. We just want a good representation of the clamp. And let's get the overall width. The bandwidth. And how about the thickness of this? Oops. And I want to change all those to 3 decimal places, so I'm going to go down here and select my dimensions, do a window around everything, properties, 3 places. Should be good enough. Yep, so our band is 28 thousandths, 5/8 wide. And the only other information we're going to need from this is going to be these slots. So these slots are going to be if you try to dimension them, you'll find that these look like straight lines, or highlighting the straight lines, but they're not, because they came in deformed. This is an IGES file. So the only dimension that we can get from here is this angle. So let's go ahead and measure that angle. Let's put a dimension on there. So dimension, let's do the line. Draw an imaginary line, because there's just a bunch of points here. So we're going to draw an imaginary line. So I'm going to select 2 points, that point there, control key down, and some point at this end, and there's our imaginary line. And then I'm going to hold the control, say OK, hold the control key down. Oh, got to select over here, hold the control key down, and let's do, yeah, this is fine, that one, and that gives us our angle, 7.5. So there's all the dimensions we need, 7.5. That's all that we can get from the drawing. These slots are going to have to be measured, so let's just measure those slots and write it down. So to measure the slot, I'm going to go to Analysis, Measure, and I'm just going to do between 2 lines. So that line, and there's one over here, right there, that line. And that distance was 0.2135, let's just say 21. I'm going to remove this one and do the line over here. There's a line over here, control key down, pick that one, and now we have the width of our slot, and we're just going to say 0.046. That's all we're going to do. So I wrote that information down. Now let's go ahead and make the band. So let me close this, let me save my drawing. Okay, we're ready to go. So let's go ahead and make the band now. And like I said, we're going to make a spine. There's going to be, the spine is going to go in the middle, and I'm going to do a quick demo before we make that to show why I'm doing it in the middle. It's because of this S. And let me demo that. Let me get out of here, and we'll create a new file, new part. We're going to call this our clamp. Before we model our spine, I'm going to model up a temporary one just to illustrate a point. So I'm going to select Sketch, and I'm going to select front plane and sketch on that plane. And I'm just going to create a line from here to there. I'll make it like 5 inches long. So there's our line. And I'm going to create an arc, a 3-point tangent end. There, to there, here, to there. I'm going to make them equal. Select OK. And then I'm going to draw an extrude. And I'm going to make it a thin. Now for placement, I'm going to use the same sketch plane. Use previous. I'm going to turn off my planes here. Now I'm just going to draw a straight line. Somewhere there to there. That looks fine. Now it's a thin, and it's creating all the material on the top side, and if I click this again, it'll put it on the bottom side one more time in the middle. But I'm just going to put it out for the demonstration here. I'm just going to put it at the top, just all the material on one side, just to illustrate something. So there's our material, and I'm going to use a spinal bend to make it form into this. Now the material will stretch to fit this spine. If it was too big, it would shrink to fit it. So let's, and we're going to make those adjustments when we do our clamp. We'll set up some relations for that. So what we're going to do is just use a bend here, a spinal bend, and it's asking me to click here to add bend geometry, and then click over here to pick the spine, and I did, and you can see it has given me a preview. It's worked fine, and there's our spinal bend. So it did stretch the material to meet the ends. You could lock that and keep it from doing it, but for our case, we want that to happen. Now watch what happens when this band gets very thick. I'm going to make it, say, 0.5. So you can see how this S is not being created correctly. It's got out like there's a different radius here. This outside radius is different from this outside radius. I want those to be equal. That's what it is in our. That's how it is in our IGES file. Those are equal. So by having the spine like this and having the material on one side, it doesn't create what I want. So I want that material in the middle so I can have the spine in the middle, and it will be equal when I do that. So let's go ahead and do that. Let's go to Extrude and Edit Definition. And this time let's put it in the middle. So that's the bottom and this is the middle. Select OK. And now you can see the spine is working fine. It's got, these are the same. And that's what we're going to need when we do our band. So let's start over. Let's delete this. Oops, forgot to delete them both. And let's redefine this. Let's delete everything we got. Go to Sketch View. Mine doesn't automatically go to Sketch View. I got it set up that way. So the first thing I'm going to do is draw a circle for the diameter, the hose diameter that we're going to be clamping. Ours has a maximum value of 2 5/8 and a minimum of 1.75. So let's set it at maximum 2.625, 2 5/8. Now this is going to be our driver. This dimension here will change. We're going to have a flexible dimension that's going to change this dimension. And that will be explained later why we're doing that. But for now, this dimension is going to change. It's going to change the size. So if we were to use this, the spine, half the material will be on the inside here, half will be on the outside. We don't want that. We want this to be the inside diameter. If we were to do this, we would get half a band thickness sticking on the inside of our inside diameter. We don't want that. So we're going to have to create our spine. This is going to drive our spine, but this is not going to be the spine. This is just going to drive it. And I'm going to go ahead and create an arc, center ends. Now this will be our spine. I'm going to pick some point here, swing it around, and click it here. So our model is going to have good geometry. This diameter is going to be the correct diameter all the way around through this. Then it's going to overlap. Okay, we're not going to go into some elaborate thing where we actually compress the hose or anything like that. We just want a good representation of the part, a good model that looks just like the part. So to get this, I need this to be 14 thousandths away from this, because the band is 28 thousandths. I need half of it to be on this side and half of it to be on this side. So to do that, I'm going to create a circle, put it at the intersection of that horizontal reference and our arc, and then I'm going to snap it to tangent right there. I middle mouse to lock it on there, so it's locked now. Middle mouse will lock it, so I have my tangency there. And now I'm going to put a dimension on there. I'm going to double click this to get a diameter dimension. And that's 0.028, the thickness of our wire. So now our wire will be half on this side, 14 on this side, 14 on this side, which matches our inside diameter. Now I'm going to create the transition where we go around that bend there, that S bend that we just demoed. And let me create another arc. And I'll go from here somewhere over to here somewhere. Don't let it snap to anything. Don't let it auto-constrain something. To do that, let me just do that again. Let me just create this arc there. See how it's trying to snap? It might try to snap the things that you don't want it to. So like if I pick here, it's trying to snap to there. You see that one, that constraint there? Watch for those types of constraints being brought in. Don't let it snap to anything. And to do that, you can hold the shift key down and it won't snap to anything. After you hold I'm holding the shift key down. If I don't hold the shift, I get the automatic snaps. Holding the shift key down won't let it snap to anything. So I'll bring it over here somewhere and create another arc, but this time it's going to be a 3-point tangent. And we'll create it something like that. And then again, from the end of there, over to there, make a tangent. So these two are tangent. I need tangency over here, so let's go grab it. Tangency. So they're all 3 tangent. So I'm going to do a corner trim, this piece and this piece. And then I want these to be equal radius. And that's what we want. Then we're going to set up some relations to get them to the correct size. But right now, I just want to demonstrate something. If I move this curve, see how these arcs are behaving? I don't want them to do that. I want them to stay on a common diameter reference. So I'm going to line these centers of these 2 arcs up to a diameter that's center of this one. So I'm going to create an arc, center and ends. Oops, center, pick here and close to there, and let's go get our constraint here, our coincident constraint. So that will line these 2 up, the end of that arc to that center. So now they're lined up. They share a common arc. They're both the same size. Now when I move this, they just this dimension here just gets smaller and bigger as I move it, and that's what we want. That's the action we want on there. And I'm going to create this as a construction line, so I'm going to click on it and go to construction. So it's a construction line. Anything that's not part of my spine that's going to be used to create my geometry, I'm going to make that construction, including this piece here. Okay, and this circle here. Alright, so anything that's not part of my spine is going to be a construction. Next, I want to set up a relationship between these arcs and this diameter, and I want this arc to be a little bit bigger than half of that diameter, which is the same basically, a little bit bigger than this radius, just a little bit bigger. And I'll show you the results of that when we create our spinal bend and what would happen if we didn't make it a little bit bigger. So let's set up a relation, and relations are in the tools, relations. Mine is in the quick access toolbar here. And to do that, you just click on relations and move it to the quick access toolbar. So I'm going to select relations, and I'm going to select the sketcher dimension 12 here. I'm going to set that equal to, I'm going to do a space equal because I like spaces so I can read it. And I'm going to select sketcher dimension 5, and I want to multiply that by 0.55, a little bit bigger than half. So there it is, down to size. Now this is driven. It's a driven, relation-driven dimension. Next I want to come over and I'm going to draw an arc here. Let's go back to our sketch tab, and I want the 3-point tangent end. Pick the end of our arc there, and now it's automatically tangent, so let's bring it somewhere close to there, and then over another one that's tangent. And then don't let it snap to anything, like see it's trying to snap to a radius, or see that radius trying to snap in, or any of that's trying to snap. Don't let it do any of that. Let it bring a point, put it on that vertical. Oh, I didn't do it. Okay, I didn't. I was going to put it on there, so let's go ahead and do that. Make it coincident. This point should be on this line. Another thing, I want this arc to be perpendicular to this line, this reference. So I'm going to hit the perpendicularity and select this piece, and now they're perpendicular, and basically that just puts it right on this line. That center of that arc is now on this line. I could have done a constraint there. I like this one better, perpendicularity. personal preference. Next part of the construction, another line from the center out to this point right there. And then I'm going to align this end to this line. So alignment, this end to this line. And I want a dimension. I want these, I don't want radius dimensions to be, I don't have to do calculations on what they should be. So I'm going to set up some other dimensions to get rid of them. I want this to be a dimension, and let's make that 0.5. And then I want to, this material is going to be here 28 thousandths thick. So the distance between these two has to be bigger than the wire, the band thickness. So if I draw a circle here, and I'm going to just put it out there, nowhere, no dimension on it, just put it out there somewhere, no constraint. It should show up with a dimension in it. Then I'm going to make a tangent, this tangent to this. Now this radius, which is this distance here, has to be a little bit bigger than the wire, the band thickness, a little bit bigger. So that's what I'm going to do. I'm going to set up this is a diameter dimension, so I'm going to go to dimension and click this once to get a radius dimension. And I'm going to make that a little bit bigger than the diameter, the wire, this diameter down here, a little bit bigger. So I'm going to go back to my relations, and I'm going to select Sketcher dimension 25. I want that to be equal to Sketcher dimension 5 times 1.1. A little bit bigger than that diameter. That's what you get. And this line, this circle, and this line construction. So far we need one more piece, and that's the piece that hangs out here. And as the clamp gets smaller, when we flex this thing, as that clamp gets smaller, this piece that I'm creating will come out further and further. So another 3-point tangent end. Pick here, the end point. It's already tangent, so just bring it out to here somewhere. And I'm going to set this up initially to be bigger than the radius of our inside diameter. So it's going to be a little bit bigger than 2.625 divided by 2 is that. I'm going to make it 1.4. See how that's sort of pointing towards my arc? I want it to point away. And we're going to set some relations up to set these up. When we create new clamps from this one, we want this to all be automatic. Like say, right now the way I'm setting it up, if I change the wire thickness, everything is going to change proportionally and I won't have a problem, I won't have failures. Just if I want to change this thickness, I want all these relations to be held true. So that if I do change it, I don't have to go in here and mess with this diagram or this curve. Need another line to go to here, and the reason why I don't like this dimension here controlling the position of this endpoint, because as this comes out, it'll fail. As soon as I try to go to 0 here and try to flip it to the other side, it'll fail. So I need an angular dimension. So I'll put it from there to there, and I'll get rid of this dimension by making a angular dimension. So from here to here is what I want to do. So now I don't have that linear dimension. Make that construction. And now for our final dimension, we're going to throw a perimeter dimension on here, and that's right here. Because when we're done, when we change this inside diameter, the length of these arcs cannot change. The combined lengths cannot change. Because the material, you don't gain and lose material when you change the size of this diameter. So we can't change or lose material. So this must remain constant. So we're going to create a perimeter dimension. So I'm going to click up here on perimeter dimension. And it's telling me to select one or more items. So I'm going to select all the pieces that are in my spine. So that piece, control key down this piece, this one, and so on. One more over here. And that's all the pieces that I have in my spine. I'll select OK. And in the lower left, it's telling me select a dimension to be driven by that dimension. So I'm going to select this one, that one that I just created. And now that's a variable dimension. What that means is this is going to change if I change any other dimension. To maintain the perimeter, and that perimeter, for some reason, Creo likes to throw it way out in space here, but just grab it and bring it back. Go to sketch view. So there's our perimeter dimension. This is going to remain constant. So even when I change the inside diameter, this is going to be constant. Well, to make it constant, this dimension will have to get bigger. And to demonstrate that, I'm going to exercise this dimension right here. I'm going to select on this dimension and modify. Let me move this out a little bit so you can watch this. So this dimension right here is going to stay constant, and this one is going to vary as I modify that inside diameter. Notice the 9.96, and you'll see what it's doing as we get a smaller and smaller diameter. And that's exactly what we want to see happen. Just like that. Cancel. And I think we're done with this, so let's select OK. And there's our curve. Let's save that. Okay, so now we're going to model the solid geometry and have it bend around here. Let me turn our planes back on. Get it in default orientation. There we go. And if I try to sketch using this sketch plane and this sketch reference for orientation, it'll be like, say, like this. And I sketch a line that goes at the end of this and goes straight out this way. As this clamp gets smaller, this point moves. So it's going to throw my sketcher off. It's going to, if it goes all the way around to the other side, it could flip the other direction. I've seen that happen. So to avoid that happening, to ensure that that does not happen, we're going to create our own orientation plane for our sketch. And I'm going to have it go to the end of this arc and normal to the arc, so that it will always be in the correct orientation. It will never change. The sketcher itself, when you're in the sketcher, it will never change. Even though this is moving, the sketch reference frame is moving with it. So to do that, let's go ahead and create a plane. I'm going to pick the end of that arc, and you'll see end of curve. Control key down, pick the arc itself, and normal, and that's what we want, through and normal. So there's our arc, or there's our plane. We're going to use that for orientation. So I'm going to set that plane to orient this in a certain way, and it's going to maintain that orientation no matter where that point goes. So now that that's set up, and let's create a sketch, extrude, and we're going to make it a thin. It's going to be 28,000, so let's put that in. And it's going to be 5/8 wide, so let's put that in. And it's going to be symmetric, so let's go to options and make it symmetric. I want the material on both sides of the front datum plane. So 0.625 symmetric about that sketch plane. And I'm going to select our sketch plane here. And Creo has automatically selected this plane here for orientation. Look at this. If I go here, it's selected the right plane. I don't want the right plane for my orientation. I want the plane that I just created for my reference orientation. So I'm going to click in this box and select the plane that I want. And this is the plane here that's connected to the end of that. So I'm going to put that one in there and select sketch, sketch view, and I'm going to get rid of this datum 1. I don't need that. Only thing you need for reference is this arc itself, not the end of the arc, just the arc. Select close, and I'm going to turn my planes off. And now I'm just going to draw a line, and I'm going to make sure it's tangent. I'll lock it on with a right click. And it doesn't matter how tall, we're going to set relations up for that. Select OK. And now you can see that our material is being created on one side. We want it in the middle now. So let's just select this and get it in the middle. Other side, and now the middle. And that's what we want. So there's our material. Let me get it into a shaded mode. There's our material, and you can see it's symmetric about our sketch plane. Half of it's on one side, other half on this side. Now what we need to do is set the relation up for this length of this piece. Because if we just use it this long, it'll stretch it around there and make our material. But we're going to be putting slots in here. And if we put those slots in there and do that, it'll just stretch those slots. So we want to make the length of this plane, this extrude here, the same length of the perimeter of this arc. So let's go ahead and do that. We'll go to our relations again. Remember, tools. It's in tools, relations. And I'm going to select on this part here, this feature. And I'm going to select dimension 28 there. That's the length. I want that length. Click in here, space equal. I put spaces just so I could read it. And I need it to be equal to the perimeter of this. And there's the perimeter. Creo puts PERIM after a perimeter dimension. It automatically does that. So I'm going to click it, and I want those to be equal. Select the OK, and I'm going to regenerate. So now this piece is the same length as that arc. Those arcs together, those curves together. Okay, so let's create some features. I am going to create a couple features that are actually not on the model, but I see it on the part. So I'm going to go ahead and create those first. Just some end tapers, lead end tapers. So I'll do an extrude, and I'm going to remove material, and I'm going to go through all, which is this one here. What does that one say? All surfaces. So it's just going to go through everything. And then for my placement, I am going to define it as this surface of our protrusion extrude right here. And it's selecting automatically the right surface to be the right side. I'm going to say that's fine. I'm going to sketch. I'm going to also need a center line down between here because I'm going to make a symmetric feature. So I'm going to need this front plane as part of a reference. So I'm going to select my references here and select that front plane. And that put a center line in for me. That's why we made the piece symmetric, so we can do this. So let's go to sketch orientation here, sketch view. And I'm going to switch off shading. And I'm going to create a center line, a construction center line, not a center line, it's a construction center line. I'll put it vertical, lined it up to there. Next I'm going to put an arc on there, a 3-point tangent end, but there's no end here. So it's not going to snap to any end. So put it there and then somewhere over here. And let's lock on right-click tangency. Let's right-click tangency there. Let's draw a line from here to here to here. And I don't want to have a radius dimension. Make sure these are tangent. Those are tangent, right? Yep. Okay. I see two tangencies there. Oh, that's tangent with that. Never mind. Okay, so instead of radius dimension, I'm going to put two dimensions here. I'm going to put this dimension, and I want that to be like 0.2. And this dimension, I want to be 0.1, something like that. That looks about right. And I'm going to mirror that. So I'm going to middle mouse to get my white arrow there and select everything. And then I'm going to go over here to the mirror tool and select the center line. So I have mirror geometry there. And next I'm going to create an arc with center and ends. Put it on the center of the arc is going to be on this center line. Down there somewhere, and put it over here somewhere, and then snap it to there, and then a line connecting them. And I'm going to make these two arcs the same. Make this one equal to this one. And I'm going to control it with a dimension instead of the width dimension from there to there. And let's say 0.1. That's too big. 0.05. And still a little bit too big. 0.03. Looks about right. And this is what we created. Right there. Just put that little in. That's a lead in for the clamp. That's what's actually on the part. So now let's put our slots in. So let's do it again. Let's do an extrude. Remove material and through all. Placement, define. Just use the previous same we did before. And we're going to need that center again. So let's go back to references and let's get that front plane. That front plane creates our center. And let's get it out of shaded mode. Okay, so we're going to start by, the first thing we're going to do is create a construction point here and put it somewhere here. And it's controlled by this dimension. Let's just make this 0.15. And next we're going to create a line. And we're just going to pick a point out here to the left and above that point. And we're going to snap it to that. And then we're going to pull it until we see an M. If we don't see an M, let's try again. Let's put it over here. Drag it. There's an M. There's an M. I could right click and lock it. So that line is, that point is in the middle of that line, so that's symmetric. These two ends of this line is symmetric about this. Next, let's put a dimension for the length of that line, and we've already measured that, and that's 0.21. And then it had an angle of 7.5, so let's put that in there. From there to there is 7.5. And that is our construction line. So let's make that construction. Click on it, make it construction. We could have done it, toggled it on and off over here with construction mode, but to me it takes too long. Arc center ends. Piece here, out to here, over to here. Same thing over there. Let's lock the radius. I want equal radius, so let's lock it with the right click. Right mouse locks it on that radius. And swing it around here. And the line from here to here, and here, and here. And let's go to tangency, make this tangent, and this tangent, and this one, and this one. And I don't want a radius controlling its width, I want a linear dimension, so I'll put from here to here. And that dimension is going to be 0.046, 0.046. So there's our first slot. Select OK. And it's still selected, so I could right click and go to pattern. I'm going to select this 1.15 for the dimension. And I'll just leave it at let's make it 0.1. That looks about right. We'll tweak this later. And let's start out with, like, say 36 of these things. So there's our slots. There we go. And now we're ready to bend this around that arc, or those curves. So let's go to engineering, Spinal Bend. This is a little bit different now than Creo 2. We want our bend geometry, so let's click here and select our geometry. And then for references, we're going to select here for our spine and select the spine, which is this. And if it was correct, it would automatically, you see it automatically snap to the, give you a preview. But it's not. And that's because our arrow here is on the wrong end. It should be on this end. If yours is there, all you got to do is pick on the arrow, and it moves it to the other end. And as you can see, it snapped right in. Now, if your spinal bend fails, a couple of things you could try. If you could fix it just by going to your accuracy, going and setting up accuracy again, and just making that even tighter, like a half a thou, and it fixes it, then you've got a piece in here that's just too small. And I found that on sometimes that these slots, when I'm modeling them, if I just change their size just a little bit, it'll work. So if your spinal bend is failing, try changing the size of your small features. Anything like this that's getting warped around here. This is basically the spine is just warping the material. So if you start failing, try changing some of your small dimensions to a little bit bigger. Not much bigger. I've actually fixed it with as little as a thousandth of an inch bigger dimension like this. This 0.46, if I brought it down, I think it would fail. I'm not going to go through that exercise, but if it does fail, you're trying to create your arc, one of your dimensions is too small, and if you need it to be that small, you need to go change your accuracy to cover that. I don't like making different accuracy parts. I like all my parts to have the same accuracy, like all my inch parts have 1/1000ths for absolute accuracy. That being said, you should be in this position right now if you were following along with me and you did everything I did. And I just want to talk about that S-curve. Remember I told you we're going to make our radius a little bit bigger than half of the diameter. And the reason I did that a little bit bigger is so as I end up with a small round here. And that's also what I mean about creating small features. By doing that, if I were to make that smaller, this will get smaller and smaller and smaller and smaller. If I would make it equal, it would be a straight edge there. There'd be a straight edge there. If I made that radius the same as the thickness of this band, that would just be a straight line. But if I made it even closer and closer, it would create these really small pieces, and you might get a geometry check. So our band is complete, and let's see if it works. Let's go down to our smallest diameter, which is 1.75. So let's try it out there. So I'm going to change this to 1.75. Make sure it works. And I'm going to be checking a lot, and when I do check, I like going to tools and making sure geometry checks is off. I don't want to see anything happening here. Any geometry checks we get, we'll fix them. And I'm going to try it. I'm going to exercise this band. Maybe I'll change this dimension, the hose dimension, by 0.1 and check, 0.1 and check, 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 and keep doing that, and I'll show you how to do that. But right now, I don't have a geometry check, and that's the way it's supposed to look. This is going to have to be tweaked a little bit, probably. That looks like a little bit too much of a gap now. But we're going to fix that. We're going to tweak all this stuff. So let's put it back to the maximum. So this number here is going to be 2.625. And let's regenerate that. And I'm going to save what I got. And now we're going to create the geometry that goes here, that's welded on.